Hello and welcome to Dr. Anima Upadhyay's Chemistry and Technology and Chemistry lecture videos. The topic of today's video is the dielectric studies on chalcogenide glasses. But before I start this video, I would like you to please subscribe to my channel if you have not done it so far, and also to share this video among those who want to seek knowledge. So let's begin with this video. Again, I have formatted it in the question answer form for better understanding and learning. So the first question is, why is dielectric strength and its study important for electronic and communication devices? The dielectric strength plays an important role in material selection when it comes to electrical insulation. Most commonly used applications in electrical and electronic industry based on dielectric strength are coating, potting, and encapsulation of electronic devices. What are the applications of chalcogenide glasses? Chalcogenide glasses, abbreviated as CHGS, are substances with wide range of applications in industries such as optoelectronics, fiber optics, IR detectors, thermoelectric devices, remote sensing, imaging and communication. Why dielectric studies important for chalcogenide glasses? Chalcogenide glasses are replacing glass optic fibers. They are also used as cladding material and insulators, as well as in optical devices and sensors. The dielectric studies of these materials helps in better understanding of these materials to be used for such important applications and also to overcome the drawbacks of the existing chalcogenide glasses. What are dielectrics? Insulating materials or very poor conductor of electric current are called dielectrics. When dielectrics are placed in an electric field, no current flows in them. They have no loose bound or free electrons that may drift through the material. Thus, they get polarized. What is the effect of dielectric medium on electrical charge and capacitance of a capacitor? The force between electric charges in a dielectric medium is less than it would be in a vacuum, while the quantity of energy stored in an electric field per unit volume of a dielectric medium is greater. Similarly, the capacitance of a capacitor filled with a dielectric is greater than it would be in a vacuum. What are the effects of the dielectric on electrical phenomena? The effects of dielectric on electrical phenomena are described as dielectric constant, permittivity, and electric polarization. What is dielectric constant? The dielectric constant of a material is a measure as its ability to store electrical energy. It is an expression of the extent to which a material holds or concentrates electric flux. How is dielectric constant expressed mathematically? The dielectric constant is the ratio of a material's permittivity to the permittivity of free space. It is also known as relative permittivity and is the electrical equivalent of relative magnetic permeability and is expressed as K, which is equal to epsilon by epsilon naught, where epsilon is the permittivity of the substance and epsilon naught is the permittivity of the free space, and K kappa is a unitless and dimensionless quantity as it is the ratio of like entities, same entities, permittivity. Different materials have different dielectric constants, indicating the extent to which they can store an electrical charge. What is an electric flux? Electric flux is the total number of electric field lines passing a given area in a unit time. What does higher and lower dielectric constant signifies? Higher K insulator compositions as high as 1200 are used to make capacitors, and low K insulator compositions where K is equal to 9 to 15 are used to provide insulation between conductors. What is permittivity? Ability of a substance to store electrical energy in an electric field is called permittivity. What happens when dielectric constant increases? With increase in dielectric constant, the electric flux density also increases, keeping all other factors unchanged. How is dielectric constant important? The dielectric constant enables objects of a given size, such as metal plates, to hold large quantities of electric charge for long duration of time. What are important applications of dielectric material? The dielectric material and dielectric properties finds applications in electrical circuits or printed circuit board, radio frequency transmission lines and communications, energy storage devices, electrical substation equipment, transformers and rheostats. What are the factors on which dielectric constant depends? The dielectric constant depends upon temperature, moisture content and frequency. How dielectric constant or permittivity affected by frequency? The dielectric constant decreases with increase in frequency. This is referred to as the Maxwell-Wagner type of polarization, which is in accordance with Cope's theory. What is the effect of temperature on dielectric constant? With the rise in temperature, the dielectric loss increases. Mobility of charge increases with temperature, which increases the polarization and leads to high dielectric loss. What is dielectric loss? Dielectric loss is referred to as the loss of energy that goes into heating a dielectric material in a varying electric field. How does dielectric behavior helps in studying chalcogenide glasses? The study of dielectric behavior of chalcogenide glasses is used to understand the structural information and conduction mechanism in chalcogenide glasses. What should be the dielectric constant of a PCB material? The dielectric constant or relative permittivity of PCB materials should be between 3.5 to 5.5. Dielectric constant level depends on frequency and it usually drops with rise in frequency. What is IR region in electromagnetic spectrum? Infrared radiation is a part of electromagnetic spectrum that lies between the visible and microwave radiation, a wavelength that is between 0.78 and 1000 μm. IR stands for infrared. Why IR study is getting momentum? IR devices using optical elements made of IR transparent materials is today's growing consumer market. They can be easily integrated or attached to smartphones. They are also extensively used in automotive industry as driving assistance during night time. How IR materials helpful in optical instruments? The IR materials has two major advantages which makes them useful in optical devices. First, night vision of bodies or objects at room temperature which emit IR radiations with the wavelength between 7 and 4 mu m. And second, the thermos vision of warm bodies or objects which emit IR radiations with the wavelength between 3 and 5 mu m. This is also useful to detect fever due to infectious diseases. What are the requirements of IR transparent materials? The important requirements for the IR transparent materials are high transmittance that can cover the range of longer wavelengths, high degree of optical homogeneity and high purity, appropriate refractive index and dispersion parameters in the IR region, thermal stability against crystallization, durability in air and against water or mechanical stress. How chalcogenide glasses good as IR materials? Chalcogenide glasses are IR transparent and easy molding, and their mechanical properties is no longer a hindrance as IR materials. What are the major constraints of chalcogenide glasses as IR materials? The stability against crystallization and extended transparency across the entire visible spectrum still remains a constraint and is needed to be achieved. What parameters we address to achieve the requirements of chalcogenide glasses as IR materials? Milling and sintering is efficient in obtaining IR transparent glass ceramics. Aging of the samples in the ambient atmosphere. Optimization of doping with barium and iodine as well as processing temperature. All these parameters influences the amount of stability of the amorphous phase of the materials. Is it possible to make chalcogenide glasses as bulk and thin film IR materials? Yes, they can be used to make bulk and thin film IR materials for optic devices. What could be deduced by dielectric studies on chalcogenide glasses? The dielectric studies on chalcogenide glasses concludes that dielectric constant and dielectric loss are temperature and frequency dependent. The dielectric constant and dielectric loss increases with increasing temperature. The increase in dielectric constant and dielectric loss being different at different frequencies. What are the RF losses referred to? The RF losses is referred to as attenuation. The losses are studied as attenuation constant alpha. Attenuation constant has 4 components and are frequency dependent. That is metal loss, dielectric loss due to loss tangent, loss due to the conductivity of the dielectric and loss due to the stray radiations. Why are infrared waves preferred for optical fiber communication? The attenuation of the fiber is much less at IR wavelengths, that is infrared wavelengths. The attenuation of glass optical fiber is caused by 2 factors, absorption and scattering. It is a function of wavelength, with longer wavelengths having much lower scattering. On what principle does optical fiber works? Optical fiber works on the principle of total internal reflection. Light transmitted in an optical fiber is confined to the core of the fiber. An optical fiber comprises of a light carrying core in the center, surrounded by a cladding that acts to trap the light in the core. Glass fiber in turn is covered with a plastic buffer coating to protect it from the environment. It also allows easy handling for splicing or termination. How? Total internal reflection helps in conduction in optical fibers. Beyond a certain angle, the refraction causes light to be reflected from the surface, called total internal reflection. Optical fibers uses this reflection to trap light in the core of the fiber. By proper selection of core and cladding materials with proper refraction index and by keeping the angle of the light below a certain angle, the angle of total internal reflection defines the numerical aperture of a fiber as a standard fiber specification. Why chalcogenide glasses considered to have good attenuation characteristics? Chalcogenide glasses have attractive physical properties such as their high transparency, high density, high atomic number, flexibility, high resistance against corrosion, good thermal stability, easy to use and easy to prepare with various techniques. Studies made on radiation shielding on chalcogenides found that these materials are not only superior to many ordinary and commercial glasses but are also better than many recently developed oxide glasses. These properties reduces losses and enhances attenuation characteristics, thus making chalcogenide glasses as good dielectric materials. State the inferences drawn on the prospects of chalcogenide glasses based on the dielectric studies. The chalcogenide materials as IR fibers is the future of optics. Improvements for IR fluorescence emission can be made in chalcogenide glass fibers by doping them with rare earth ions. The high quality chalcogenide materials with low loss and high strength, that is single and multimode fibers, will improve the capabilities of existing and emerging technologies. What are some common dielectric materials and their dielectric constants? Some dielectric materials which are commonly used and the dielectric constants are tabulated here. You can go through these. Here are the research papers which I have referred in the text within the brackets. You can go through them, and if you want to go into deep research, you can follow these references. I am happy that I have covered most of the important questions which could be raised while studying the dielectric studies on chalcogenide glasses. Thanks for watching this video till end. Don't forget to subscribe to my channel and also to share this video. The important links on chalcogenide glasses which I have already uploaded in the past, you can see in the description box. Thanks for watching.